For each function, state whether it is linear. A linear function follows a set pattern. For example, this is a linear function. If I put an x value into my function, my y will be 5 more than that. So if I drew a table, I end up with if x is 1, y is 1 plus 5 or 6. If x is 2, y is 5 more. If x is 3, y is 5 more. So on and so forth. If I look at my patterns, it has to be constant. When my x goes up by 1 point, my y goes up by 1 point. This is also a function. Still the same x's, 1, 2, and 3. But now, if x is 1, it's 2 times 1, which is 2, plus 5, which is 7. If x is 2, that's 4 plus 5. If x is 3, that's 6 plus 5. But my pattern between my y's is still constant. So to figure out if a function is linear and you're given ordered pairs or a table, you have to ask yourself, is the difference between my x's constant? And is the difference between my y's constant? So let's see how that looks. First one, you have ordered pairs of 0, 3, 1, 7, 2, 10, 3, 11. Remember, an ordered pair is just x, comma, y. So let's look at the difference between my x's. I'll use red. My x's, from 0 to 1, I'm just adding 1. From 1 to 2, I'm just adding 1. From 2 to 3, I'm just adding 1. Awesome. Constant. They're all just being added by 1. How about my y's? From 3 to 4, and remember, for linear, you're only adding or subtracting. So from 3 to 4, 3 to 7, sorry, I'm adding 4. From 7 to 10, I'm adding 3. And from 10 to 11, I'm adding 1. This is not constant. They're not the same number. Therefore, this is not linear. In fact, that graph would look something like this, a curve, because I'm growing at different paces. So the first one is nonlinear because the y's are not growing or shrinking by the same value. Second one, my x's, from -5 to -3, that's +2. From -3 to -1, that's +2. From -1 to 1, +2, awesome. From -4 to -9, that's -5. From -9 to -14, that's -5. From -14 to -19, that's -5. Awesome, linear, done. So all we have to do is check it. Same thing with my tables. 3 to 5 is +2, 5 to 7 is +2, 7 to 9 is +2. -5 to -7 is -2. -7 to -3 is +4. -3 to 1 is +4. These are not all the same, so it is not a function. Even though the last two start to get linear, it's not linear. Even though the last two start to be the same, that -2 between -5 and -7 messes it all up. So, not linear. Last one, -1 to 3 plus 4, 3 to 7 plus 4, 7 to 11 plus 4. Your y's, 4 to 8 is +4, 8 to 16 is +8, 16 to 32 is +16. Or technically, you're just multiplying by 2 each time. So this is also not linear, because these numbers are not the same. Again, with linear functions, your y values has a common number that is being added or subtracted between all of them, and it's the same if your x's are also being added by the same number. So those are how you do those functions. I'll do one more. I'm going to choose to do function number 4. My x values, 1 to 4 is plus 3, 4 to 7 is plus 3, 7 to 10 is plus 3. Negative 3 to negative 3 is plus 0. Negative 3 to negative 3 is plus 0. Negative 3 to negative 3 is plus 0. Notice how they're still increasing by 0, which counts. So function 4 would be linear. And the other 3 you can figure out using the same math we've done thus far. And that's how you figure out linear functions. If your x's are either increasing or decreasing by a common value, your y's must be increasing or decreasing by a common value. Only through addition and subtraction. And that's it.